Hi everyone, this is Hossein from EJ Academy. In this video, I wanted to use calculus concept, specifically integral, to solve a problem for you. So as you can see, we have a graph here. I have a parabola and the equation is shown, and then I have a straight line. And the question is asking to find the slope of the straight line such a way that the area above and below that straight line confined by that parabola is the same. So it means that, let me show it on the graph. So it means that we wanted to find the slope of this line, assuming this line is y equal a times x. A is the slope of the line, which is unknown. We wanted to find it, and then we wanted to find the slope such a way that this area above the line, let's call this A1, is equal to the area below the line. Let me shade that area. Okay, let's call this area A2. And then the question is asking to find the slope of the line such a way that A1 and A2 are equal. Okay, let me show you very quick on Desmos. What does it mean? So we have a parabola x minus x squared. Let me zoom in. And then we have a straight line. The slope is a, unknown, times x. And then let me use a slider here. Okay, we want, so as you can see, I'm changing this the slope of the line here. We want to find the slope of the line such a way area above and below are equal. Let's say, for example, like here, around here, the area above and below, I think in this condition, they're roughly equal. It seems, at least to me, they're equal. So as you can see, the slope in this case is 0.225. So we wanted to basically calculate the slope of the line, using the integral concept. So let's go back to the notes and start solving the problem. Okay, on the side, I'm going to write a reminder for those who are not familiar. So if you have two curves, let's say, let me see, if you have a curve like this one, let's call this one y1, and then you have another curve like this one, let's call this one y2, and this is our coordinate system, x and y, and then we wanted to find the area confined in between the two curves. So this area is calculating using this formula. So we take the integral of y1 minus y2 dx, and the limit for the integral is from a to b, which a is this intersection here, and then b is this point. So the limits are from a to b, and the reason that we subtract y2 from y1 is because y1, the values of y1 is larger than the values of y2, and we wanted to get the area to be positive. We don't want it to have a negative area. That's why we subtract y2 from y1. Okay, knowing this, let's go ahead and solve the problem. So before using the integral, I wanted to find the points of intersection for this parabola, which is one here and one here. So if I say y is equal to x minus x squared, this is the equation of the parabola. And if I set this to 0, then I can find the intersection of this parabola with the x-axis. So I factor x. So I have 1 minus x. X times 1 minus x equals 0. So this equation has two answers. One is x equals 0. The other one is x equal 1. And these are the 2 points of intersection, or the roots of this parabola. One is 0, x equals 0, and this one, x equals 1. And also I wanted to find the point of intersection between the straight line and the parabola, which is here. I wanted to find this point. So to do so, I need to set the equation of the parabola equal to the equation of the straight line. Now I subtract both sides by a times x. And then doing so, I have x minus a times x minus x squared equals 0. And then I can, the first two terms, I have x, I have, so I'm going to factor x. So I have 1 minus a times x minus x squared equals 0. Then I have a common factor x in the two terms. So I'm going to factor that. So x times 1 minus a minus x equals 0. So this is very similar to the first equation that we had above here. So this one also has two answers. One is x equals 0. The other one is x equal 1 minus a. And you can also see that on this graph. So the intersection of this line with the parabola is 2 points. So we have 1 point here, x equals 0. The second point is 1 minus a. So go to the new page. So knowing that, we can find the area above the straight line, A1. See this area above the straight line. So we wanted to use this concept here. So this is our y1 and this is our y2. And the limits of the integral is from 0 to this point, which is 1 minus a. So I'm going to write that down here. So from integral from 0 to 1 minus a, and then y1 is the parabola x minus x squared, minus y2 is the straight line, a times x. So I'm going to enclose that in a pair of brackets times dx. So it is, before solving this integral, I wanted to rearrange the terms. So integral from 0 to 1 minus a, I'm going to combine these two terms because they both have a common factor x. So I have 1 minus a times x minus x squared. Then I can solve the integral. The first term So this first term here, 1 minus a is constant, and then x is the variable, and the integral is going to be 1 minus a, which is the multiplier, and then the integral of x is x squared divided by 2. And then the second term, x squared, the integral of x squared is x cubed divided by 3. So minus x cubed divided by 3. And then the limit of integral is from 0 to 1 minus a. So if I put 0 in the integral, the lower limit, so both terms are going to be 0. So that makes my life easier. So I'm going to put the upper limit 1 minus a. I'm going to substitute that into the equation. So I'm going to have 1 minus a times 1 minus a squared divided by 2, and minus 1 minus a cubed divided by 3. And then if I do the multiplication for the first term, I'm going to have 1 minus a cubed divided by 2 minus 1 minus a cubed divided by 3. And then if you do this subtraction, you get 1 minus a cubed divided by 6. Okay, this is a1 in terms of small a, which is the slope of the straight line. Now, this area, we want to have this area to be equal to a2, which is this area below the line. One approach is to just find or calculate the area A2, which is, I see a right triangle here plus this little area here. But I think it's easier to just find the area under the whole parabola from 0 to 1 and then divide it by 2. I think this approach is easier. I'm going to use this approach. So let's call A is the total area under the parabola. And then this is equal to the integral from 0 to 1. The reason is that the parabola intersect with the x-axis at 0 and 1. And then the equation for parabola is x minus x squared times dx. So if I do the integral, so integral of x is going to be x squared divided by 2 minus the second term, the integral of the second term is going to be x cubed divided by 3. And then the limits are from 0 to 1. The lower limit, like the previous integral, if we put 0, so both terms are going to be 0. And then the upper limit, if we put it into the equation, let me write it in a clear line. So it's going to be 1 squared divided by 2 minus 1 cubed divided by 3. So it's going to be 1/2 minus 1/3 is equal to 1/6. And remember, this is the total area. We wanted to have A1 that we found up here. We wanted this one to be 1/2 of A, because A is the total area. So A1 is equal to 1/2 of A. So A1 is, we found it up here. So A1 is 1 minus A cubed divided by 6 is equal to 1/2 times A. A is 1/6 times 1/6. And then this 6 here in the denominator on the left-hand side is canceled with the 6 in the denominator on the left-hand side. So what I have here is 1 minus A cubed is equal to 1/2. Then I take the third root from both sides. So I have 1 minus A equal to third root of 1/2, which is equal to third root of 1/2. Third root of 1 divided by third root of 2, which is equal to third root of 1 divided by third root of 2. So A is going to be equal to 1 minus 1 divided by third root of 2. So let me use my calculator to find this number here, 1 minus 1 divided by third root of 2. So this is equal to roughly 0.206. So this is an estimate. So if I go back to Desmos, so I can remove the slider. So I can, instead of A, I can say 0.206. So as you can see here on this graph, the area above and below the straight line are equal using the slope equal to 0.206. I hope this example helped you to understand better, understand the integral better and get more familiar with the concept, and give you some insight about using integral to find area under the curves. So if you have any questions, you can always post your questions, leave comments below this video, and I try to get back to you as soon as possible. And don't forget to like this video and also subscribe to our channel for future videos. Until next video, bye everyone.